we're going to look at probability as it applies to two-way tables, Venn diagrams, and the general addition rule. You have seen a little bit of this in an earlier chapter, so some of this will be familiar to you, but then we're going to add a little bit more of the probability rules that go with it. So we have here a table where we have two categories, whether or not a person has pierced ears, yes or no, and what gender they are. The first question says, what is the probability that a randomly selected student is male? So we look at the total, all of the males, divided by the total number of students. So we have 90 out of 178, which is 0.506. What is the probability that a student has pierced ears? Well, we look at the total of pierced ears, 103, divided by 178, which is 0.579. What is the probability that a person is male and has pierced ears? So that they are in both of these categories. Well, that would be this group right here. 19 males have pierced ears, so that would be 19 out of 178, or 0.107. This last one said is the probability that a person is male or pierced ears. Pause the video and take a minute to think about what that would be. Okay, so we have this, so here's the group that has pierced ears. Here's the group that are male. We can't just say 90 plus 100 and 103. For one thing, that would be 193, which is more than we have total possibilities. If we did that, it would be counting this group of males that has pierced ears twice. So basically, we'd take all the males and then add the females that have pierced ears, or all the pierced ears and add the males that don't have pierced ears. But we're looking at these three numbers right here. These are the people that have male, or they are male or have pierced ears. Notice we only have one group that doesn't fit in either category, so really we could just say 178 minus 4, or we could add up these three groups. But it's 174 over 178, or 0.977. Now this leads us to one of the two big formulas that's on the probability sheet, or on the AP formula sheet for probability. And this says the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. Now symbolically, and is represented by an upside down U, kind of like the N in and, or the N in intersection. Or is represented by, is called a union, it's represented by an right side up U. You can think of or includes more people than and does, so or is kind of opened up, whereas and is kind of shut down and more exclusive. So we could write this as probability of A or B, right side up U, equals probability of A plus probability of B minus probability of A upside down U and B. Now if we applied this rule to what we did here, probability of male, let's just have that be A, that would be 90 out of 178. Probability has pierced ears, let that be B, would be 103 out of 178. Obviously adding those together is more than 178. So we have to subtract out the group that is both male and pierced ears, minus 19 out of 178, because they have been counted twice, and then we get the 174 out of 178. Now, do I expect you to understand this rule? Yes. Do I expect you to necessarily use it? Not necessarily, because you don't really need to. It's much easier just to read the information off of a good chart or diagram. Here's another way to organize the same information. In a Venn diagram, one circle represents one category, and one variable, and one circle represents the other. So we'll have this be male, or I should say one event, and this is pierced ears. Okay, so I have labeled M for male and E for pierced ears, E for ear, because probability of P gets kind of confusing. So here symbolically is how we say male and pierced ears. That would be this group in the middle. So group number 1 would be male and pierced ears. That would be 19 people. Group number 2 then is male and no pierced ears. So that would be the remainder of the circle. So the males that don't have pierced ears, that would be the other 71 of the males. So total in the yellow circle are the 90 males. Then group 3, so that's group 2. Group 3 is in the rest of this pink part. That would be, they're not male, but they have pierced ears. So that would be the 84 females that have pierced ears. So altogether, 19 plus 84 gives me the 103 that have pierced ears. Then not male and no pierced ears would be group number 4. That would be the 4 people out here that don't fit into either category. So both tables, two-way tables, and Venn diagrams are a very good way to organize two variables. When you're looking at two variables of data, it's a very good way to organize the information. I would recommend then that you try now problem 316, number 56. Can you organize this information? And I will put the answers here. There's more than one way to do it, but pause the video, try it, and then I'll show you one way that I did it. Okay, first of all, I wrote down the given information. Probability was a Mac user, probability that they were undergrad, probability of grad and a PC user. Obviously, if they weren't a Mac user and we're assuming all the rest use PCs, then that would be 0.6. And if the undergraduates are 0.67, then the graduates would be 0.33, because that would be the rest of the students. Organizing the given information, we were given marginal probabilities, how many used a Mac or a PC, how many were undergraduates or graduates, and we were given one of the conditional probabilities, or one of the combined probabilities of grad and PC fit here. So then all I have to do is figure out these three by saying, okay, if 2.23 is the grad users that the PC users that are graduates, then there has to be 0.37% undergrads that use PC, because it has to add up to 60. Then once I get that value, then these two have to add up to 0.67, and these two have to add up to 0.4, or these two have to add up to 0.33, so I can get all of the other numbers. Putting this in the Venn diagram, this would be PC and grad. This would be the PC users who are undergrads. This would be the grad students who don't use a PC, who use a Mac. And these would be the ones that don't, they are undergrads and they are Mac users. So they're not in the PC group or in the graduate group. This is the way symbolically to write the answer, to do the part C, probability of grad and Mac user. And then the way I got the information would be just to look at my chart. I have made good charts, so I don't need to use a formula to figure this out. We talked about not using a bald or a naked answer. Actually, I didn't mention that before in the video. Many probability problems involve simple computations that you can do on your calculator or in your head. It may be tempting to just write down your final answer without showing supporting work. My supporting work here would be my table, but I could also say I know that 10 out of 100, every 100 people are graduate students who use Macs, so that would also give me the 0.10.